Thank you for joining, also people online. Yeah, big audience. I'm Tim Elfrink. I'm from the Netherlands, and I'm a machine learning engineer at StepStone. For the people that are not really from Germany, StepStone is a job marketplace, so we try to find the right job for everyone. And we have different machine learning algorithms that we are deployed on websites, and I want to show you how we do this and what kind of patterns we use for this. So as I mentioned, we have different machine learning models, and one of the models is salary estimations. So we have a model that if you give some input about yourself, you can get some estimations, so it makes you easy if you find new jobs, if you get offers, if it's a fair offer, yes or no. And you have to fill in a small questionnaire, and when you do this, we have a prediction. So how does this work? You give some information about yourself, so your location, what's your job title, what's your experience level. Our model will do the magic, and then there's like some kind of output coming out of this. And how this works, like on the website, like really basic is, okay, we have a user interacts with the front end. There's a backend service there that is querying our model, or like sending requests to our model, and then we send this information back. And most of the things are just handled by the backend server, only like this couple of values that we are trying to get for the specific user. And we have, within our company, it's not super strict, but we have like different responsibilities. So we have like software engineers and, that are more for the front end and back end. We have machine learning engineers, data engineers that are really for the serving part. And we have the data scientists that are more focused really on the output of the model, what's the quality of it. And today I won't really talk about the data science part and the software engineer side, but I will really focus on the model serving part. And a couple of things that I will go through when talking about different patterns. I will talk about the latency. What that means is how long does a request takes, the throughput, how many requests can the service handle in a given time unit. So let's say our throughput for certain services like 10,000 requests per hour. Availability, so is our service always available, or maybe sometimes it's not available because there's some scaling going on. Resilience, so what happens when there's like a spike in traffic, can it still handle this? And also a big factor is like cost. So of course we can just deploy like our model with a really big server, and then we can handle all the requests, but probably then yeah, the company will go bankrupt. So I won't focus on like security aspects, like alerting, monitoring, like the model updates, and also I won't really focus like machine learning inference on edge devices, because we don't really do this, and I'm not really an expert in that. So back to our first example. This is an example of like real-time inference. So we sent a request, and we get something back. And how like this is good for use cases where you need low latency. So what it is like front-end service. So the user interface. So like people expect when they submit their survey that they get immediately like something back. It's also, in general, low throughput use case. Like if we have like 10,000 people clicking on the button at the same time, getting some requests, probably our model server will go down. And we have a couple of those examples within StepStone, that we have like a candidate fit score that you get, job title recommendations for recruiters when they create like jobs, and like the salary estimation planner. And how can you deploy this? Like, so really this model serving part, for example, just like scikit-learn with in Fast API, you just build a Docker around it, and you just have like your service. And how do you actually scale this? So as I mentioned, there's one easy way to do this, is just like get a bigger machine. So you just calculate what will be your peak traffic. You just estimate, okay, then I need this machine, and you just deploy it, and then you will be always safe. One more cost-effective way is to actually deploy like it in smaller machines, and have a load balancer together with the auto-scaling group, like pick, okay, which services are now idle and I can use. So like this is like, yeah, classical vertical versus horizontal scaling. And the first one is like, yeah, you over-provision, and the other one is like really based on traffic. So if we see there's like more load on our services, we can just spin up more machines in the cloud. So that was like one of the things that we can just do is like if we get a lot of requests, we have just auto-scaling groups there that we can, when there's a lot of traffic, we scale out. When it's like in the night, like there's not so much traffic, so we scale in again. And we can, in our service, we can also add some caching. The nice thing about this like real-time inference endpoint is that you can also add some other services. So not only like your backend service, but also internal use cases can use this prediction service. So what we usually do, we have our services, and before we actually go live, we have like, I don't know, some kind of Streamlit APIs that we can have some playground for product owners where you can actually put in some values and you can actually get some answers. And we also supply this with, I don't know, some SHAP values or other things, but really that people early on in the project, before we actually deploy this, also can interact with their model. So this looks super similar to the first slide, but this is a different product where we also do salary estimations, but these are salary estimations just for a job location and a job title. And we have that in a lot of different locations on our website that we have those estimations. And what we here just can do is we can have all combinations that we want to put on our website. We can already put it like in a big file. We can make those predictions and we can just store this in the database. So we don't need any real-time inference. What we just do, we just have like a Docker container, or like maybe it can even be like a notebook that reads like all the different combinations, loads the model that the data scientist made, and then you do a prediction and you store this somewhere. And then you can just store this in some kind of database. So, as I said, this can be like a notebook, can be like a Docker container, this can be also like a GPU cluster if you have large language models. So you can make this as complex as you want. And one example where we use it with StepStone is every night we have a job that is calculating what will, or like predicting how many applications will we get for every specific job. So we have just like, yeah, a trigger every night. We have all the different jobs with their features, and then we make the predictions, and then we store this in our database. And how do the services then like query this? Well, just the application server, like our backend, can just read from this database. So then we just pre-populate this database every night. And this works really well. And also this database, if we just have like a key value storage database, nowadays they're like super fast, so you have like, they scale really well, and you have like really sub-milliseconds response times in the cloud. So the nice thing is that the application really doesn't know actually anything about the model, so you kind of decouple this from your application. So how do we actually also scale this? So let's say we have to handle like 100,000 of listings in a night. We can actually just partition the input files, maybe in 10 different files. And we have like a processing container that we also partition. So we have like 10 containers running there that creates the files in the right input. Then we have the models that also are different containers, like we can just scale that. And in that way, let's say one model can have like handle 10,000 items in an hour. Now, then you can just have 10 machines running in parallel, and you just do like 100,000 in an hour. So like this scales just like horizontally. So that works really nice in that way. The only issue is that you have like a cold start problem. So what I mean with this is like we have also products that we, for example, recommend jobs for specific jobs. So you have a listing. There's like, oh, maybe you also like those listings. And if you do this every night, this can be an issue. Because we have a new job that is just being published. it is not being found in the night yet, so we don't have any predictions there. So we need to have some like tailor-made solutions there, maybe some business rules, maybe looking at similar listings and then just give the same recommendations there. So there are like some caveats there, but it's like really, it's really good for if you want to do like high throughput predictions. Okay, another use case, again salary. So we also have salary estimations on jobs. So if you are looking for a job, and we try to make it transparent for people that search jobs, okay, what kind of salary can you expect here? And this is something that not all companies, especially in Germany, are really transparent about, and we try to like kind of push this with some estimations here. But what this means is that every time there's a new job being posted, we need to also have some trigger that we say, okay, well, what is then the salary? So we have to use our model again. And how we do this is just in a asynchronous inference way, so like in an event-driven way. So we have like incoming events. We are reading from like a queue, and our model is like, it can be like also just this fast API endpoint again that is, instead of getting HTTP requests, it is just pulling from some kind of queue. It's one by one grabbing all the events and then making predictions and then put it in another queue for another application to pick this up. And within StepStone, we have a lot of use cases where we actually have this event-driven way. If there are new listings or new candidates sign up, or maybe someone applied for something. So we have like a lot of different use cases for this event-driven way. And some of our use cases have issues. For example, the real-time endpoint, it can take quite a time. So maybe like for large language models, it's now, I don't know, depends what model you have and what kind of container or like instance type you're putting it. But it can be like 20 seconds before like a response is coming. And that can be an issue if you have this real-time endpoint and you actually have to keep this connection on all the time. And in this way, there's no connection. There's just like pulling and pushing all the time. So again, how do we make this then scale? So we have some data producer. So I don't know, some kind of application within our system is notifying us, okay, there's new listing coming. So at that moment, it's being populated. And let's say we have 10,000 items. Maybe there's like a new CRM system that is pushing all their jobs to us. So we have 10,000 events in there. Then our model can pick them up one by one, but you can also, again, scale the model so you can have like multiple instances that are consuming from the same queue. So you can, again, compute in parallel. So this queue is going way faster. And then you put it again in your prediction outputs queue. And then there's some kind of service that like picks us up. Maybe there needs to be some post-processing being done, and then it is being populated to the database again. And as you can see here, again, we have the same pattern that actually our backend server has no idea actually how the models are there. They're just like querying our prediction service, and we are just reading from our database. So like again, this decoupling, which is for our backend team, I think quite nice. Also, the other nice thing here is that in the night, again, there's like not so many recruiters that are publishing new jobs for us. So sometimes there are just no requests coming in. And what you then can do, you can just like shut down all the instances from your model, and you don't pay for those GPUs anymore. And then at the moment there are like, again, events in the queue, you can just spin up a new machine. It doesn't really matter, like there can be like a million events still in this queue, and it doesn't really matter if it's being picked up like now or maybe in half hour. So in this way, we can also optimize a little bit on cost. The disadvantage here is that maybe it's a little bit more complex than like just a simple real-time inference endpoints, because you have those queues and maybe also like the consumers and the producers for the events. And just like the batch process, the backend needs to know that there might not be a solution there. So like a prediction there. So like maybe the prediction, like the request is still in the input queue, and people are already going on the website to request like the salary estimations, but they're not there yet. So like the user interface needs to just be aware that this can be empty, that we send like request back like, no, it's not there yet. Yeah, one thing, like when I like this queuing system, like this asynchronous way, can scale really well. So like you can just put like 1 million events in there, and then the model will just pick it up. You can just scale. So why would you need to have this batch process still? Well, how this works is that most of the models, if you do like one individual request 100 times, the time that it takes is longer than if you just do it in one batch. So like this dot predict, and then you just do it in a batch, because there's a lot of optimization happening already in the code. And how to solve that is like, with this asynchronous way, is like instead of getting one by one all the events, you just grab them in batches, and then you put them together and you make the prediction, and then you split it again for the prediction outputs. So this works well, and it comes close, but it doesn't really, like still, if you want to optimize on cost or on GPU power, I would go for like the batch process, because you will save quite some cost, because the other one has quite some overhead in that, and will just be, in the end, slower for the same compute. One other thing that we have is serverless compute. Like it's kind of a combination. Like if you're aware of like the cloud providers, like you have Lambdas in AWS, you have Azure Functions, Google Cloud Functions, and they all work kind of similar. So like this function is not really like a container that you pay for per minute, but you kind of pay like for the request times. So it will scale like super good. So you can have so many concurrent requests. You don't really have to care about any containers anymore, so this can also be like a good way to deploy your models. The only thing is that, yeah, it doesn't really work, like there's no, at least in the big cloud providers, there's no like GPU serverless instances at the moment. So for quite some use cases, it doesn't really work. Like also the memory and the CPU needs to be like, are a little bit restricted. But if your model fits on it, it can be really good and also cost-effective way to deploy it, and it can be triggered by HTTP requests, but it can also just by events, like with asynchronous way. So when to use what? So like this is just like a summarization what I just had. I hope all the values are correct. Let's see about it later, if I get some comments about it. But the only caveat is it might be a real-time endpoint. Like the costs are high because you always have it if it live. But it might be the case that if you compare, for example, with batch, and you want to pre-compute a lot of combinations, and you need to have a lot of compute for that, it might actually be just beneficial to have like just one real-time endpoint running if you just don't have so much traffic. So like everything, like it just depends. So what we actually do with some of our projects is like combining or different architectures. So like or patterns. So like we have a project that we are summarizing job listings. So this can be super useful if you are on the mobile phone and you have this long job listing that you just see a couple of lines, or we do it for email campaigns or for chatbots. And the way it works is that every time we have a new listing, so we use the asynchronous way, every time we have a new listing, we just process them. We have like a large language model behind us, so we do some prompting, then we send it to the model, then we are doing something with the output, and then we store it again in our prediction database. And this works really well because there's a little bit of an issue with those large language models, as I mentioned before. They can be a little bit slow, so To put it somewhere else might not really be that good. And also we want to have it actually as soon as possible. But what we also have is we notice that because they are completely automated, we also want the end users to have a little bit of control with it. So we want them to also be able to change them or maybe to regenerate them if they want to change it. So we still also have our real-time inference endpoint, but then it's in a certain way facing that the users know that they have to wait a little bit. So they are pre-populated, but they can be regenerated on the fly if necessary. So in this way, we can combine them. Okay, so now we have actually all our different summaries always in our database. But now we have something that our data scientists have new iterations of their model, and we actually want to improve our model, and we might have like a different output. So then we have all the listings that are now online. We want to reprocess with our new model and make sure that they are now also being shown to the end user. And then we use our batch process. So then, because it's the most cost-effective way for us, because we have to use our GPUs, we are using the batch process there. We just get all the information, all the listing text there. We put them in some kind of big job, and then we process the output and put them in the database. So I'm a little bit at the end already. So what I would advise if you start with your projects, like start simple and really like look at the different patterns that are out there. Like how do you want to serve it? Are people expecting to have an answer immediately? Are they able to wait? Do you actually need to have some endpoints, or can you just keep it with some kind of batch process that you just run in the night and everything will be fine? Yeah. So actually that was it, and I hope you learned something, and thanks all for your time, and if you have questions, come to me after the talk or now, or find me on LinkedIn.
Thank you for the great talk. We have a lot of questions, so
Oh no.
we should start with the first one. That's the most upvoted one. Could you add 10K by standard to all estimations so we get more base salary? Thank you.
Okay. Yeah, just send me a message and we can change a little bit.
So, second one. Can you share details about the data set size you use to make predictions and whether it's typical developer who submits data?
Yeah, so I covered quite some use cases now. So yeah, it really depends. So like for example, our recommendations systems, they're really dependent on like who is actually applying for the jobs, like which jobs did they visit, did they get hired, yes or no. So that's all like click data. We also have other data that we just collect from our users by filling in some information. Yeah.
Okay. Next question. Which technology do you use for the message queue?
We use Kafka, but like it doesn't really matter. Yeah, like the idea is like it's more here, not really focused on technologies, but more like on the patterns. Like we also used the RabbitMQ in the past. Yeah.
Does queuing your input not make the end-to-end user latency higher?
Does
queuing your input not make the end-to-end user latency higher?
Yes. So like that's why we are like really beforehand thinking, okay, when are the users going to see it? And for us, it doesn't really matter. So like with the listing predictions for those salaries, we don't really care if those listings, the estimations are on there right at the moment that the listing is online, or maybe half hour later. Like the end users don't really care. The listing will be there online for like a month, so that delay is okay. But as I mentioned in the beginning, there are some use cases that this delay is like, we should care about, and that's also why we then choose other solutions.
All right. Have you considered deploying and running models into the front end with frameworks like Onyx, Web Runtime?
Yeah, there's for us no need for that. I think our front end is already pretty complex with a lot of different services there, so it doesn't really fit in our stack, I would say, but it can be a possibility, yes.
What is your take on managed API serving with, for example, AWS SageMaker or Azure ML?
Yeah, it can work great. So we have services running just in those fast API endpoints, but we also have it in SageMaker. The nice thing about those managed services is that they orchestrate also a lot, so it's really easy to do some auto-scaling there, for example, like it's really built in. And also they are coming with some model registry, which is pretty nice because we deploy it in different patterns, and then yeah, you just pick, like you reference the same model, so that makes it nice to not kind of reinvent the wheel that you have to do your own model versioning there.
In your experience with asynchronous inference, does Fast API able to deal with tons of events-driven requests? Do you apply any optimization on the endpoint?
I don't really have experience with that. So like, we are now using ourselves SageMaker, asynchronous endpoints, and there we actually send SNS topics. Now it actually works is yeah, pretty simple. Like you send the topics with an attachment where the payload is, with the location to an S3 bucket. So like then in the like SageMaker is kind of fixing it for you, so you don't really know it as end user. But that's how it then works in SageMaker. So like you always have like reference to like what data, like with in our use case like the prompts, and then you also, when it is done, there's a message back with also reference to the output in like some kind of S3 bucket.
Okay. Do you have country or even region-specific models or a global one?
So our salary models, they are all country specific. We don't combine any data there. We did it in the past, and we found out specific models work best. And I think that is for most of our models that we have or language specific or country specific. We have one model that I helped develop is like the summarizations with the large language models, and actually there we have like just one model, and it can pick it up really good if you have like an English prompt and you actually ask for an English summary, or if you have a German prompt and you ask for a German summary, and that works just fine in this model. So yeah, it depends.
Based on which triggers are models retrained?
Also depends. So like our salary models, they are retrained every couple of months, because you can imagine that if you have your salary estimation that we give you now, maybe in 1 year that changes a little bit. Some models, they are more static than others. So like, yeah, it depends on the use case. And it's like also more like a data science questions. They have to know the business needs, and then they can kind of tell us like, okay, when do we need to retrain it?
Where do you deploy these different architectures?
Yeah, so we do it in SageMaker. We have some lambdas there, so that's like the serverless components. For example, in the if we have like the in the asynchronous one, all those services, they're all lambda based. So there's like the serverless components there. So like if there's actually nothing happening, then we also don't pay for anything there. Yeah, and also the database is the DynamoDB, so we also only pay for like the consumption of it. So that makes it, I think, cost efficient.
Is it vanilla scaling as with Kubernetes, or is it custom?
Yeah, so not Kubernetes, but yeah, it's like I think they have behind SageMaker like some similar technique as ECS.
Why serverless compute only works on low CPU and memory? Could you elaborate on that?
Well, there's some limitations with like the amount of data that can be in those containers. Yeah, it's like, and it's also really product specific. So maybe I know a little bit about AWS, and if you have load just or big models, it doesn't work. If they're a little bit smaller, they work. Yeah.
How do you handle cold start during scaling?
Yeah, so if it's like, usually we don't really care that much. and it depends again per use case. So if the use case is really critical, we just over provision a little bit. So we make sure that we never have like timeouts there.
So the time is quite over, but if you like, we can do some more minutes into the coffee break.
I think people can come to me. Like, I don't know if it's relevant for everyone, but I will stay. I will be here still. Yeah.
All right, then thank you.